Hello all. So in this class we will discuss about the characteristic of Regula-Falsi method. So here I have mentioned some basic characteristic of this method. Basically here we will have the characteristic of this method over the bisection method. Okay. So before going into the detail of these all points, let's have a look on the difference between these two methods by the help of a numerical problem. So this is my question. Locate the root of this equation f of x, that is x to the power 10 minus 1, between the range is given as 0 and 1.3 using bisection method and Regula-Falsi method. So we will use this equation f of x for the solution of these two methods so that we can have a good comparison between these two. Okay. So we have this range 0 and 1.3. So it is sure that the root will lie in between these 2 points. So let's check the value of f of 0. So what is f of 0? So by putting the value of 0 in place of x in this equation, I got the value of f of 0 as minus 1. And the value of f of 1.3 is coming as something like 12.78. You can check with the help of calculator. So for the solution of bisection method, I can say that f of 0 gives the negative value and f of 1.3 gives the positive value. So here I will take a as 0 and b as 1.3, right? So this is the first step solution for the bisection method. Okay. So let's have a look on the complete solution. Yes, here I have solved the complete equation using this bisection method in this table format. Okay. So here you can see the value of a is kept as 0 and the value of b is 1.3. So according to that, I got the value of f of a, f of b, and I have used the equation x equals to a plus b by 2 for bisection method. So I got x1 as 13 by 20. Right. So here f of x is how much? That is coming as negative. So for what is the updation for next iteration? For next iteration I will use, if this is negative, that means the a is going to change. Okay, the procedure is same what we have seen. So according to that, I got the value of x around 1.00039 and it gives the value of f of x as 0.003906. Okay, that means it is giving the error of around 0.39%, which is very less. So I have considered this as my answer. So my root is this. Okay, and I am getting this answer for the 8th iteration using bisection method. So let's have a look on the same equation using the Regula-Falsi method. So this is my solution for the Regula-Falsi method. Okay, for the same equation. So here again in the question the interval was given as 0 and 1.3, right? So according to this solution, what we used to do? We used to do that whatever interval is given at first, that we will take as a, and whatever interval is given second, that will be considered as b. Okay. So you can see a is 0 and b is 1.3, right? So using the Regula-Falsi equation, I got the value of x1 and f of x1. And for further iteration, I got the respective values of x and f of x. So here we have a look that at 8th iteration in bisection method, we got the answer of the root around 1.0003, and here I am getting the root at around 0.588, and that too f of x value is very large, is minus 0.99. Okay. So this value cannot be considered because here we can see that the value of x1, x2, x3 and at x8, it is changing considerably. The value is going from 0.33 to 0.40 to 0.47 to 0.53 to 0.58. So there is a large difference in between each iteration. So that means we cannot take the answer right now. So we have to go for the further iteration. So let's have a look on the next iterations. So here I have shown it. So you can see I have solved this question up to the 20th iteration. Okay, and at 20th iteration I got the value of x20 as 0.955, and here also I am getting minus 0.366 value. Ideally, what should be the value of f of x? F of x value should be 0. At that time only we can get the ideal root. Okay, so it is giving minus 0.366 value. So there is huge error at this iteration also. Okay, so what we have to do? We have to go for further iteration. Yes, so I am having now the next iteration set. So here I have solved up to the 32nd iteration, and here I have the value of this, that is 0.9978983, and this is the value of f of x, and still I am getting here error of around 1.99, that is around 2% error. Okay, and I got in bisection theorem the error was around 0.3%. So still we need to go So this is my further solution. So here we can see at 39th iteration the value of xn is this, and I am getting f of x like this. Okay, so here I can say that I am getting a very considerable error which can be neglected, that is of around 0.3% what I have solved for bisection method. For that value I am getting the root of this value, that is 0.9983. Okay, so this is the solution for this question. So here we can have a clear difference between these two methods, that for this particular question I have 8 iteration for bisection method, and for the same solution I need to go up to the 39 iteration using this Regula-Falsi method. So up till now we have seen the Regula-Falsi method was giving a better convergence than the bisection method, but for this question that all conclusion violates. Okay, so this needs to be considered, and this is another characteristic of the bisection method, right? So characteristic of Regula-Falsi method, let's discuss now. So this is the characteristic of this method. So first point, it gives a bracketing method. Bracketing method means what? We have some interval here, some range here, and in that range we need to work. That is the value of a and b. Okay, like in this question we have seen the value of a was 0 and b was 1.3. Okay, so this solution works on a bracketing method. Even the bisection method also works on a bracketing method. Now what is the next point? Next point says false position is often superior to bisection. Yes, it is often superior to bisection, but there are invariably cases that violate this general conclusion, like we have seen in just the last question where this conclusion violates. For that question, bisection method gives the better solution than the Regula-Falsi method. Okay, another characteristic, a major weakness is it gives one-sidedness. One-sidedness, what does it mean? Suppose I have a curve, we have discussed in the Regula-Falsi method first class. So suppose this is my curve and here I got some interval of a and b. So for this I have this f of a and I have this f of b. Okay, so what we used to do, we used to draw a straight line between these 2 points, and then consequently or at the given iteration value we used to draw the further line. So what is going to happen? One of the interval getting fixed here and another interval is getting changed for the all time. Okay, that means one interval is becoming fixed. That is called one-sidedness. Okay, so this value is fixed for calculation and this is only going to change. So that is called the one-sidedness. Because of this, if the curve is flat, so like this suppose, and I have got this interval, then this method will go for a number of iteration like we have seen in the last class. So this is a major weakness of this method. It gives one-sidedness, right? And what is the last point? That one-sidedness can lead to a poor convergence. Yes, particular for functions with significant curvature. Significant curvature means if we have a curve of flat nature, that gives a poor convergence for this method. Okay, like we have seen in the last question. So that last question was about the f of x equals to x to the power 10 minus 1, and if we compare that with the help of this graph, so this is the graph for this equation. So we can see this is the range where we are getting a flat curve. Okay, so because of this flat curve we are getting a poor convergence, you can see, and I got the answer of the root at 39th iteration. So this is one of the major drawback of this method. So I hope you got the clear understanding of the Regula-Falsi method compared to the bisection method.